Hello everyone, this is the last video this week, and in this video I will be discussing expected shortfall, an approach for measuring market risk, and also regulatory models for measuring market risk for financial institutions. With regard to expected shortfall, as mentioned earlier, a criticism of value at risk measure is that it tells the financial institution manager the level of possible losses that might occur with a given confidence level, that is the 99th percentile, assuming a normally distributed return series. Expected shortfall, also referred to as conditional VAR, conditional value at risk, and expected tail loss, tells us the average of the losses in the tail of the distribution beyond the 99th percentile. Okay, that is, if 1 in every 100 days there is a loss, expected shortfall tells us the average of those 1 in 100-day losses. Okay, so for example, if I go back to a table that I showed you in the last video, you can remember here that the financial institution's 99% confidence level VAR was this, $97,210, assuming a normally distributed return series. So it means that for this financial institution, the value of the portfolio will decline by 97,210 in the 1% worst possible case. Okay. However, you understand that for many return distribution, there can be fat-tailed. So fat-tail means that there is a possibility that there can be worst cases below this 1%. So in that case, if normal distribution is fat-tailed, for example, like this, you can see that here VAR 99% VAR is negative 97,210. It means that 1% chance that the value will decline by this 97,210 or more than that. However, due to this fat tail, the average of the losses of these 1% cases will be higher than this 97,210. Okay, so you can see that the average of these 1 in 100 losses will be higher from this. Now, value at risk corresponds, VAR corresponds to a specific point of loss of the probability distribution, for example, 99% VAR. It does not provide an information about the potential size of the losses that exceeds it, that is, VAR completely ignores the patterns and severity of the losses in the extreme tail. So it ignores the pattern and severity here. It just points out this 1% worst possible case. Thus, VAR gives us only a partial information about the extent of possible losses, particularly when probability distributions are non-normal. Now, if we look at this example here, you can see that we have two securities, for example, security A and security B. There is a 50% possibility that the value will be 100, 49% possibility that value will be 80, and 1% possibility that value will be 920 negative. And 50% possibility that the value will be 100 for security B, 49% possibility that value will be 92, and 0.25% possibility that the value will be negative 920. So at this point, that at this 1% cases, because it already covered 99%, you understand. So at this 1% case, the value will be negative 920. So VAR of security A and VAR of security B both is negative 920. Okay. However, for security B, you can see that this to a 0.25% cases, it can be negative 920, and 0.75% possibility that it can be 1,704 negative. So if we calculate the average of these losses, For example, 25% case, it will be 920, and 75% case, it will be 1,704. So expected shortfall for security B is 1,508. So you can see that it's much higher compared to the 1% VAR. Okay, so that's the advantage of expected shortfall, that while VAR reflects one particular point, what's the possible loss in 1% worst case, expected shortfall tells us the average of the losses in the trade. Now, regulatory model, since January 1998, banks in the countries that are members of the Banks for International Settlement, that means BIS, have been able to calculate their market risk exposure in one of the two ways. That means in the regulatory purpose, the banks are calculating their market risk in two ways. The first one is the simple standardized framework that we are going to discuss shortly. And the second one is with local regulatory approval, is to use their own internal model. So what I'm trying to say is financial institution may use a standardized model suggested by Bank of International Settlement, or they can use their internal model. However, to use this internal model, that has to be approved by the local regulatory authority. So when banks use a standardized model to calculate market risk, a standardized model is suggested by the regulatory authority. One standardized model that is used is partial risk factor approach. So in partial risk factor approach, it actually applies risk weights to the market value of trading portfolio securities with enhancement to prudently reflect hedging, often diversification across securities. So in this case, I know the main objective of calculating market risk by those regulatory purposes is to have adequate capital, is to have capital adequacy to face this risk. So in this case, financial institution follow several steps to determine their capital requirements. First of all is they assign instrument to each asset baskets. For example, what they do is instruments are placed in one of 20 asset buckets across each 5 risk class according to their risk maturity. Okay, so 5 risk classes are foreign exchange, interest rate, equities, credit, and commodities. So all the instruments that a financial institution holds, they under each of these 5 risk class, they create 20 buckets and they put their instruments in one of these 20 buckets under each of these asset class. Then what they do is a risk measure is calculated for each of the bucket using a regulatory specified formula, which is essentially based on expected shortfall estimate that we just discussed. So market value of the asset in each bucket are then multiplied by the risk weight. And then the risk measure of the individual asset bucket. So what we do is, first of all, we calculate the risk measure for each of the bucket. Then the risk measure of individual asset bucket are aggregated to obtain capital requirement for the trading portfolio. So the risk is calculated for the trading portfolio and they find out what is their capital requirement to face these unforeseen risk. Now, Basel, the Basel 2.5 requires a particular process that financial institutions follow when they use their internal model to calculate capital charge. So first of all, in calculating DER, daily earning at risk, financial institution define an adverse change in the rates in being the 99th percentile. So they consider the risk will be calculated based on 99th percentile, which means that they will multiply the sigma by 2.33. We already know this number. Then financial institution assume the minimum holding period to be 10 days. So they will calculate daily DER, then they will calculate 10 days DER. Okay. We also know that when we have a daily DER and we want to calculate 10-day DER, daily DER should be multiplied by the square root of 10. In the previous video, we have discussed how DER is calculated. Now, financial institution also add a stressed VAR that is intended to replicate a VAR calculation that we have seen previously. that would be generated on a financial institution trading portfolio if the relevant market forces were experiencing a period of stress. That means in a normal condition, calculating only DR is fine. However, if a financial institution is going through a stress period, then a stressed VAR need to be added. The stress VAR is based on a 10-day 99 percentile VAR of the trading portfolio with model inputs incorporating historical data from a year period of significant financial stress. Okay, so in addition to the normal VAR that we calculate, we should calculate a stressed VAR, which will be essentially the VAR for a 1 year of very stress period that a financial institution experiences historically. Then as they have them, they just calculate a standard model to find out a capital charge. What actually they will do is the higher of the previous day's VAR, which is, for example, the GR multiplied by square root of 10, and the average daily VAR over the previous 60 days time is a multiplication factor with a minimum value of 3. So the capital charge will be GR multiplied by square root of 10 multiplied by 3, which will give them an estimation of the capital charge or estimation of the capital requirement they're supposed to have. For example, then let's say that VAR is 10 million and multiplied by the square root of 10 multiplied by 3 is 332.04 million. It means that for a financial institution which has a $10 million VAR should have 332.04 million capital charge to face the risk associated with this level of VAR. So that's the end of our discussion essentially. So you understand that in this week we have learned what is market risk, why market risk estimation is important, different models or different approaches to measure market risk, and also regulatory models. Thank you very much.